This is Mick Elliott, electronic specifier at the Rohde Schwarz stand at Electronica. We're looking at a brand new oscilloscope to the Rohde Schwarz portfolio. And I'm with Jithu Abrahams, who's going to talk us through some of the assets of this product. But first of all, Jithu, could you just talk a little bit about the genesis of the development of this product?
Sure. So it came about where we had a lot of performance capabilities on our higher end oscilloscopes, where we developed a lot of custom ASICs, a lot of performance capabilities into those scopes to allow people to do fast measurements, make reliable measurements, and so on. And we had a cost-optimized design in our lower-end portfolio, and really we wanted to merge these together right bang in the middle of our portfolio, so where customers get a much affordable scope, but still have all those performance capabilities and so on, those hardware key components to really make measurements much more efficiently, much more better. And so on.
I mean, how did you pack all those features into this, and you're able to offer it, as you say, at a more affordable price for certain customers?
Sure. It's mainly looking at the design from every point of view. So it's starting from the front end itself, what analog components can be used to make the noise of the instrument really, really low, and then looking at the ADC technologies that are out there to really get the best resolution possible for power signals, for these really stringent signals that we see today out in the market. So we have a new 12-bit ADC technology there to help with getting more resolution, and for people who want to get even more, we went even further to give 18 bits of resolution in certain different conditions. And then once you have all of that data, how do we process that data? How do we really get insights to engineers much quicker? And here we used the knowledge that we have from our higher end oscilloscopes to build a custom ASIC that's really the heart of the instrument, back end to really get the data, crunch the data and put it onto the screen real quickly. This ASIC is responsible for triggering, for pixelization, for pretty much a lot of operations, and to keep the scope responsive, fast, and being able to deliver that data really, really quickly.
I mean, that is a feature, the acquisition rate.
Yeah, exactly. So one of the highlights that we have on the MX-04 is its fast refresh rate, or update rate as we call it. So it's the means by which we can look at the live data, we trigger on it reliably, and then how fast can we push it to the display. And here we use the ASIC. This is the main reason why we can get that. And we can achieve about 4.5 million waveforms per second. So it's the fastest oscilloscope that's out there in the market today.
The other thing engineers are always after, and it's a bane for them, is overcoming noise problem. I mean, I believe this is very low noise as well.
Yeah, exactly. So we try to keep the components that we use and so on for the different parts, if it's 1 mega ohm or 50 ohm parts and so on, really, really low, so that the impact from the scope itself is very minimal. So on the scope itself, you see in microvolts of range of noise, so that anything you're characterizing and so on, you can still see the ripple effects, you can still see small, minute details and things on the screen, on the scope of the instrument. So yeah, so to really pinpoint what might be going on your instrument, and it's not buried in the noise floor of the oscilloscope.
And can you talk us through the digital trigger and what that brings in?
Yeah, sure. So one point is, we designed the front end, we designed the ADC, so you can actually recreate the signal, but a big factor for oscilloscopes is triggering. So yes, I can see that signal detail, but I'd like to have a stable waveform to make measurements or quantify where is this occurrence coming from. And here we use our digital trigger architecture, which we did do, 10, 12 years ago in our higher end oscilloscopes, and now bringing that into this class of scopes, again through the ASIC. So the ASIC is really looking at the live data and being able to do a full trigger capability on those signals. What that gives engineers is a really low sensitivity level. So generally on scopes you have about a division or maybe more of sensitivity that you need to quantify a valid trigger. On ours, it's 0.00001 of a division, so it's like really, really tiny that you can actually pinpoint and actually see these small signal details and make sure that this is something that's repeatable or so on, and then you can actually find it.
And it's capable of RF measurements as well.
Yes, so one thing that we were conscious about is our heritage for RF measurements and so on. So we hear from a lot of customers that, yeah, it's great that you see it in time domain, but would love to see another perspective of it. So, and this is why we built a spectrum analysis capability on our oscilloscopes. And here we have, again, what we wanted to achieve was again a fast refresh rate. So we have about 45,000 FFTs per second. What that means for the engineers are that infrequent events that you might see very rarely, it just pops up on the screen. You can immediately see it, and you can then say, oh, that shouldn't be there, or try and quantify, set up trigger conditions and so on to really say, okay, where's this coming from my board? So getting that insight from another perspective to really find out what's going on.
And there's an arbitrary generator in there as well, isn't there? Yeah.
Exactly. So for some signals and from some applications, we try and merge different instruments together. So not having to go and grab another instrument to generate something, sometimes is handy just to generate a clock signal or a modulation scheme, or even to capture something on the scope and replay it back through the generator and so on. So we have a dual generator that's capable up to 100 megahertz to enable those kind of conditions. Okay. Yeah.
I mean, one thing, looking at the scope is it's a nice compact size as well, so it's not going to take up a lot of desk space. Was that something that you were thinking about in the development?
Absolutely. So desk space is a big factor, and we looked at a lot of different aspects of the scope, so being very small in terms of depth, but also keeping a large screen in the front and so on and things, so that users still can make use of the real estate of the scope itself. And we also employed a Visa mount capability on the scope at the back of the instrument, so that for those engineers who need more space, they can put in a monitor arm or something like this to really squiggle and use more of the desk space if they need to.
And you've combined touchscreen and rotary as well, if people my age prefer.
Indeed. So we have various types of users and so on. Some people who love touchscreen, some people not so sure, and some people who love still the hard keys. So we kept a certain level of hard keys, nicely labeled out and so on, so that hopefully it's easy to find what they need and keep those, some are bigger, some are smaller and so on, just so that it's easier to get to. And with the touchscreen interface, we really put in a lot of effort to define the UI itself, to make it, doesn't take time to learn a new instrument and to concentrate more on the signals that you want to capture. So it's things like where, we put in a lot of effort into maximizing the waveform area of the screen, to put in all the menus into one place, and you can find everything that you need in this one place. You put toolbars on the top, so that constant tools that people every time want to use. I don't want to find it through a menu. I'd rather just have an icon for doing it. So things like this to make it simple.
And the product is available now from Rohde Schwarz and distributors?
That's correct, yeah. So we launched it at end of September, and now it's available through all of our distributors, through directly and so on. So yeah, anyone who's interested can come up and have a look and have a play.
Okay. Jithu Abraham, thank you very much indeed.
Thanks so much, Nick.
Okay, cheers. Thanks.